Hey guys, welcome back. Today's lesson, what we're going to be talking about is just scatter plots in general. So you might have worked with these back in Algebra 1, back in ninth grade or so, maybe 8th grade for some of you. So maybe it's been a while since you've constructed one of these. We did a couple of them also at the beginning of the semester as well. So we're just going to kind of run through some of the scatter plot basics and some of the functions on your calculator that are going to help you out with future problems in this particular unit. Okay. So what we're looking at here, we have some data. We have the number of tardies here in the top row and the number of missing assignments down here in the bottom row. And I'm going to mark the number of tardies with an X and the number of missing assignments with a Y. So indicating I'm letting my X variable represent the number of tardies and I'm letting the Y variable represent the number of missing assignments. Right, and before we get to constructing the scatter plot, the reason that we like scatter plots and a lot of what we're going to be doing in this unit relates around trying to connect two variables. All right, so one variable being the number of tardies here, the other variable being the number of missing assignments. And what we want to know is there some kind of connection between being late to class and having missing assignments? And the appropriate mathematical word for that is called correlation. And the easiest way to see whether or not two variables are correlated to each other is to look at the graph and see if there are any discernible shapes. Are there any obvious shapes that are taking place when we build that scatter plot? Right. So the way that we build a scatter plot is on a coordinate plane here, just like this, with an x and a y axis. You'll see that my origin is located right here, and we're just like we would back in Algebra 1. Okay, so this first point is at 6, 6. I'll plot a point there at 6, 6. And then the next point here is at 13, 11. So I'll go to 13, so 11, 12, 13, and then up to 11, which is right here. And then we'll do 10, 13. And from there, you can just fast forward from there, and I'm gonna get the rest of these points just plotted instantly in the video. Okay, so that way you don't have to sit here and watch me plot points. I think you guys get the idea of how to plot points here. Okay, so there we go. I've got all of my points plotted here. So this is a scatter plot that represents our two sets of data for tardies and missing assignments here. All right, so that was doing it by hand. It's real simple. You just plot the points, but I also want to show you how to do it on your calculator as well. So the calculator can be a lot quicker than doing it by hand sometimes. All right, so go ahead and grab your calculators and turn them on. And before we do anything with this type of data, the first thing that I want you guys to do is to turn your diagnostics on. Okay, so if you go to mode, you're going to go down here to this line where it says stat diagnostics, and I want you to make sure that that is on. Okay, so later on in the unit, we're going to be doing something called a linear regression, and certain things may or may not pop up if you do not have this turned on. So if you're missing stuff, like if you're missing r and r squared later on, you'll need to make sure that you have turned this on. So don't forget this. Hopefully you guys catch that in this video. All right. So to create a scatter plot, we're going to go to the stat plot option right here. It's in blue, so we have to hit second and then y equals. And we're going to go to stat plot 1 and turn it on and select the very first one here. This is the scatter plot option. And it's going to ask you where you put your data, which means we need to actually go and put our data into the calculator. So I'm going to put the x variables. I'll put the number of tardies into list 1, and I'll put the number of missing assignments into list 2. All right. So I'm going to leave this alone for right now. I'm going to go to stat, and I'm going to go to edit, and I'm going to make sure that my data is put into list 1, right? So I'm going to put all the tardies here in list 1 and put all of the missing assignments here in list 2. All right, so go ahead and pause the video and enter in your data. Should look just like mine. Okay, so now that we've got all of our data entered in, we're going to go back to our stat plot and just make sure everything's good there. And so second y equals, and go to option 1, make sure it is turned on. And a lot of students forget that. Make sure stat plot is selected, and then L1 and L2 should be here in the X and the Y list. All right, and then I want you to go ahead and hit zoom option 9. Okay. And I'll show you how to get that line in just a minute, okay? So let me see if I can actually get rid of that line so you can see it. And I'll show you how to put that in there later. But your stat plot should be here on your screen. So when we did that zoom feature, it was zoom option 9. It said zoom stat. That's the one that you want to hit because it'll automatically fit your screen to your data so that you can see your scatter plot here. All right, and it should look very similar to what you did by hand. All right, so that is our scatter plot. Now, the next thing we're going to do is we want to draw what's called the line of best fit into our scatter plot. All right, so you'll notice that the points seem to be making a linear shape here. It's not really making a curve or anything. So we're going to be doing a linear regression here. So that's why we're going to draw a line. So let's go to stat, and we're going to go over to calc, the calc menu, and we're going to select option 4 here, which says linreg. That stands for linear regression, and it's going to create an equation for the line of best fit for us in the format that we're probably most familiar with, which is our y-intercept form, right? mx plus b, but they use an a instead. All right, so we'll go to option 4. And then it just wants to know where your data is. So your X values, your number of tardies are in L1, your number of missing assignments are in L2, and then you're going to go down. Don't do anything with the frequency list, but when this next one where it says store the reg EQ, that means regression equation. So where do you want to store the regression equation? We want to tell it to put the regression equation in Y1 so it'll graph the line for us. The quick way to do that is to hit the green button, alpha, and then trace. You'll see in green here it says F4. All right, and we want to put it in Y1. So if you just hit 1 from here, it'll insert Y1 in here, and it'll take the equation that it calculates and it'll input it into the Y equal screen so that it'll graph the line. Okay. So here's what linear regression does. It takes us to the screen and it shows us what the equation is, right? So the a value in this equation, or the slope of our line, is going to be 1.18, and the b value, which represents our y-intercept, is going to be at negative 1.45. All right, so we have the form of our equation. This r squared and this r, we're going to write that down a little bit later. But for right now, if you just hit the graph button, it should automatically graph the line for us. And that is our line of best fit. All right. So over here in our notes, what we're going to talk about is what's called the strength, direction, and form of our scatter plot. All right, so we'll start with strength first. All right, and what they're referring to when they say the strength of a scatter plot is how close all of these points are to the line of best fit. So if these points are all really close to this line, we would say that it has a strong linear correlation. And based on what I'm seeing here in the calculator screen, it certainly looks like a very strong linear correlation. None of these points are really far away. Like I don't have any points way over here, way over here. So this is a strong correlation. Okay. The next thing it wants to know is direction, right? You should be able to talk about the direction of the line. Okay. So if we look at the direction, it's going up and to the right, so it's increasing, or it's got a positive direction. Okay. So a positive slope or a positive direction. And then the last thing it wants is the form. Right? And if we were doing other types of regression like exponential regressions or quadratic regressions, you might see the points make a parabola or an exponential curve or something like that. This is making a line. So when we talk about the form, this is making a linear form. And usually the form is what you look at first so you know what type of regression that you're doing. But it was pretty obvious when we made the scatter plot in the beginning that it was trying to make a line. It wasn't making a parabola where it was curving or anything like that. So the form is linear. So we used our calculator to find these numbers already. So let's go grab those one more time. I'm going to quit out of my graph here, and I'm going to run that linear regression one more time. So I'm going to go to stat, over to the calc menu, option 4 one more time. And let's get that. Let's get that stuff, right? So this R value, right? The very first one here, the R value, they want is 0.945. And this is a numerical way of determining the strength of our correlation. All right, so this number 0.945 would indicate a very strong correlation because it's very close to 1. All right, so if this number R that we get from the calculator is really close to 1 or -1, it would indicate a very strong correlation. If it's a positive value, we would say it has a positive correlation. If it's a negative value, we would say that it has a negative correlation. All right, the next value that they want is R squared, right? And it's literally taking 0.945 and squaring it to get this one. All right, and that they do for you here. So we got 0.893. And this is what's called the coefficient of determination. And we'll talk about what this number means a little bit later. All right, then the next thing we're going to ask for here is what is the actual equation of that line that we drew up in our graph, that line of best fit. All right, and so we're going to say that it gives us a slope here. So we're going to say 1.1825x minus, all right, because the b value is negative here, so minus 1.45. Right? And this equation is what we're going to use to make predictions if the correlation is strong enough. Right? So we really can't use this equation that comes out of the calculator if this number doesn't indicate a very strong correlation. So be cautious when you get to future problems. If you do not have a very strong correlation, you cannot be using this to make predictions. But for this example, we do have a pretty strong correlation, so we can go ahead and make some predictions. So let's see what that looks like. All right, so let's say we run across a student. I wrote a student twice. So assuming a student has 11 tardies, what would the best predicted number of assignments missing be? So knowing that a student has 11 tardies, what does that mean for the number of missing assignments that they're going to have? So I'm going to take this 11 tardies, right, which, remember, tardies is represented by our x variable. So I'm going to take this 11, and I'm going to come up here, and I'm going to plug it in for x, right? So I'm going to say y equals 1.1825 times 11 minus 1.45. So I literally took this number and plugged it in. That's all I did. Okay. And if we calculate this, right, if I actually run the numbers here, what we should get for our output is 11.5575, right? So remember, y represents the number of missing assignments. So we just figured out that this student is probably going to have 11.55 missing assignments based on the number of tardies that he took. We would predict 11 to 12 missing assignments for this student, right? And again, it's just a prediction based on the data that we have, right? So you start to see the power of doing something like this, where we can find two things and we can establish a correlation between them. And once we've done that, we have a model that we can use to make predictions about something, right? So a lot of times scientists do this, like, you know, if they can predict your height based off of your shoe size. They can predict your IQ based on brain size, you know, things like that. So we love to be able to make predictions using data, all right? Try it one more time. Let's say we have a student that has only one tardy, right? So this time when we make our substitution, we would do 1.1825, but this time we would only substitute in a 1, and then we would still have a minus 1.45 on the end here. And if we crunch those numbers correctly, what we're going to get is a negative 0.2675. And this kind of helps us understand the scope and the power of our data, and that this is predicting that a student is going to have negative missing assignments, which is clearly impossible. You can't have negative missing assignments. The lowest number of missing assignments that you can have is 0. So the logical conclusion here would be that if we had a student that had one tardy, we would probably predict 0 missing assignments. Okay? So 0 missing assignments. We would not predict that they would turn in negative missing assignments. All right. So if you were writing out your conclusion in the context of the problem and you actually said negative 0.2675 missing assignments, I would mark that wrong. That doesn't make any sense. All right. So just make sure you're using common sense when you're using these models. They do have scopes and limitations to them. All right. Now this next page is just a kind of a series of notes, things that you should know. And like I said, this was all stuff that should have been covered back in Algebra 1. But like I said, this lesson is just about reviewing stuff about scatter plots from Algebra 1 and from the beginning of the semester. All right, so just kind of go through some of these bullet points here. So that R value that we found, that 0.945, that value that we get from any linear model is always going to be a number between -1 and 1. All right, it's never going to be anything. It's not going to be 2 or 3. It's always going to be a number in between 1 and -1. All right. Now the size of the correlation R, right? So that R value indicates the strength of a linear relationship between two variables, X and Y. Right? So the values of R close to -1 or 1 indicate a strong linear relationship. So you want to be close to 1 or you want to be close to -1. Right? If you're not close to those, you can't really establish a linear relationship. And we're actually going to be using a hypothesis test to determine if two variables are correlated strongly enough for us to make a prediction. That's going to be in future lessons. Okay? So typically we want those things to be close to 1 or -1. If we ever run into two variables that have a correlation coefficient of 0, that means there's absolutely no linear relationship between those two variables. It's rare that that happens. Usually there's some correlation, even if it's just a little bit. It's rare to run into something that is equal perfectly to 0. Also, it's very rare to run into something that is equal to 1 exactly. All right, that means that you have a perfect positive correlation. You would make a perfect straight line with all of your data points. That almost never happens in the real world, right? So you'll be close to 1, but you won't be perfectly 1, right? Now remember that R does have a sign, right? So for our problem that we just did, we got 0.945. It was a positive 0.945. And what that indicates is that the slope is going to be positive. So we have a positive correlation, is what they call it. Right, so the line increases as we go to the right. So as x increases, y tends to increase as well. All right. If we have a negative value of r, it indicates a negative slope, which means that as x increases, y is going to go down, right, or it's going to decrease instead. All right. So that's all there is to say about r. Now this r squared variable, it's a little bit more complicated to understand. But it's usually stated as a percent. All right? And the reason being is because we can actually determine a percentage of explanation. All right, and it has a very specific type of interpretation, and it's probably the most important interpretation that we can get from this particular test. All right, so r squared, when expressed as a percent, represents the percent of variation in the variable y that can be explained by the variation in the variable x using our regression line. All right, so for example, put that in the context of our problem that we just did. We can say that approximately 89% of the variation in the number of missing assignments can be explained by the variation in the number of tardies. So as the missing assignments, right? So when we looked at the missing assignments, those numbers changed. They deviated from that line a little bit, okay? That deviation or that variation in the number of missing assignments can be explained by the variation and the deviation in the x variable, which is the number of tardies. In fact, at 89% of that variation can be explained by the variation in the tardies. All right, so it's a pretty powerful statement. It tells us how that variation is controlled. All right, now conversely, we can use the complement as well, right? So if 89% can be explained, that means 11% cannot be explained. All right, so when expressed as a percentage, it represents the percent of the variation that is not explained by the variation using the regression line. In other words, 11% of the variation in the number of missing assignments cannot be explained by tardies, right? And that makes sense because people don't miss assignments solely because of tardies. And the tardies are not going to explain everything for why students don't turn in certain assignments, all right? There are other things that happen. But it does seem to have a pretty strong correlation between the two. We can use tardies to make a prediction based on the data that we got from that problem. All right, guys. That's enough for today. It's just some basic intro to scatter plot stuff. There's some problems there in the homework. I would definitely recommend practicing those. And if you have questions, let me know. All right, guys. Have a good week.